Okay, so I think we can start, and let's start with the schedule. Okay, I updated the schedule yesterday for next week. I mean, this week is almost over. I mean, today we will going to see these topics, and tomorrow there will be the lab for the other two groups, groups number 2 and number 3. And then we will go on next week with the same schedule. Okay, so labs and lectures both on Monday and Thursday. So there, I mean, I was not so clear about the composition of the groups. I'm sorry about this. I mean, my colleague Antonio told me to clarify this. I mean, this is the division of you. I mean, according to the last name in the groups. Okay. I mean, as I said, it's flexible as long as we fit into in the room. Okay, and we don't see that there's a slot which is basically not used. Okay, so let's say we use the first 1, 2, 3 weeks to see how it goes on, and then we will decide in case is there any change that is needed and so on. Okay. Okay, good. So if there are questions, you're more than welcome to ask. Otherwise, I think we can go on, and we proceed with the next topic. Okay, which is this keyword. Okay, you already have the slides online. Okay, and so we are going to talk, I would say briefly about this topic. I mean, this keyword in JavaScript. Okay, we already saw this keyword because we talked about constructor functions, and you used this keyword with my colleague Antonio during the example. Okay, you constructed basically a sort of a class. Okay, where you have a constructor function, and then you can initialize properties of an object and so on. Okay. So it is worth spending some more words about this in JavaScript because it behaves quite differently from other object-oriented programming languages. Okay, so you see this does not refer to the function in which it appears, does not always refer to the current object. Okay, because functions are not always bound to objects. Okay, we can call functions without object and also as properties of an object. Okay, so it's quite peculiar. This does not refer to the context and does not refer to the object that generated the call. Okay, but it's very useful, so we need to learn these rules. Okay, so in short, this when it is used inside a function is always bound, so attached to a certain specific object, and we need to understand which one. Okay, and to understand which one we need to refer to the call site of the function. So we are inside the function. This function has been called somewhere. Depending on where this function has been called, we have a certain value for this, so that this is bound to some object. That depends on where the function was called. Okay, so it does not depend on how the function is declared. So it's not about how we declare the function. It's not about where the function is declared. Okay, and we will see a notable exception. So arrow function behaves a little bit different, but differently from this rule. But we will talk about this in a few minutes at the end of these slides. So what is a call site of a function? Where this concept is similar to other programming languages. I mean, a function is called. It means that you create an entry on the call stack. And so when you call a function, you can go back in one entry on the call stack, and that is the place where the function was called. Okay. Actually, it's really normal behavior like any other programming language. Of course, the same function can be called in many places. Okay. each time the call site for that invocation is the only important function. So it means that the same identical function called in different places in different ways behaves differently with respect to the this keyword used inside the function. Okay? So you are inside the function and you need to think where and how the function was called. Okay? That's the rule, basically. The golden rule. That means the rule that covers everything except arrow function. Okay, so what is the call site of a function? I mean, it's just, you know, the usual stuff. I mean, you define a function, you define another function, and so on. At a certain point, you call a function. Let's say this buds. Okay? And this is the call site for the function buds. Okay? You call another function bar. Okay? This function bar is defined here, but it's called here. Okay? This is the call site. This is basically where you put the rounded brackets. Okay? And so that is the call function. And I think it's clickable and we can see the demo. And we will have another demo later. Let me see. Yeah, it becomes big. Okay, so just you know, try. And you see, this is the call stack where functions are accumulated. I mean, if they are called one inside the other. And when the function returns, it's popped out of this call stack. And at the end, of course, there's no function remaining in this call stack. And if you go back one place here in this call stack, you find the place where the function was called. Okay? That's really the actual definition of where the function was called. Okay? Okay, good. So now that we know where the function is called, well, we have different ways of calling the functions in general. Let's say normal, traditional function calls without involving objects and anything. Okay? So here a default rule applies. And when we are in strict mode, this inside the function is undefined. So it means we shouldn't use the this. Okay? It doesn't make sense to use the this. We are just calling a normal function without objects and so on. So, I mean, there's no object. So there's no point in using the this inside the function. Okay? And so in strict mode is undefined, but unfortunately, when you are not in strict mode, this is the global object. And depending on the environment, can be, you know, the Node.js global object or the browser global object and so on. So please try not to use the JavaScript without a strict mode, okay? Because, you know, it gives you the possibility to do very complicated and difficult to understand things that we don't like, okay? So in short, if we are calling a function without, you know, objects and so on, it is useless to use this, and we should forget about the this. Okay, it's undefined anyway, so it doesn't help us. Rule number 2, this implicit binding. I mean, if it's called in the context of an object, so it means that there's a property of an object that is a reference to a function, and we call this function with this syntax. Okay, inside the function, we will have the this bound to the object on which the function was called. Okay, so this inside the function foo is the object obj. Okay, so you see the example here. We have an object a2 and foo. That's a function. Okay, a reference to a function. We call foo on the object obj, and the this refer to the object obj. Okay? And so we can say this.a, and it will return, give us true as the value of the expression. Okay? I mean, it's quite reasonable. You call a function on an object, and inside the function, the this refers to the object on which the function was called. Okay? Just be careful because this is JavaScript. So You see the example here? You take the object.foo, you assign it to another variable and you call it bar. Okay? This is actually the same function. It didn't change anything with respect to the previous slide. That's the same function. But this time, the call site is not here. Not object.foo with the brackets. It's here, bar with the brackets. Okay? And here, the call site means that we go back to the, default binding. I mean, it's like writing this expression, foo, without the object. And so, in this way, we lost the reference to the object. Okay? So, when you execute the same function with the same this and so on, the this will not be bound to the object obj, just because you assigned object.foo to bar, to another variable. Okay? So just be careful. In short, it means that if we need to use objects and this inside functions with objects, we should always pass, the object, so that when you call the function, you write object.function, and you don't lose this binding between the this and the object. Okay? Okay. So just be careful of these situations. So let's see the right example. So we have obj, that's exactly as before. Function do foo, okay? And do foo, we passed obj.foo, okay? And so it's copied, okay? And so in short, this will not work, because when it's called, actually in the previous item on the call stack, it's called without the object. Okay? Again, that's why it's so important to identify the call site. Okay? Because depending on the call site, the this will assume a certain value or another one. Okay? So it means undefined, basically, in strict mode. Okay? So, must be careful, always pass objects, never functions, if you want this to work in the passed object. So, instead of passing functions, as previously done here, you pass the object obj, so that when you call here the function, you can write obj.function. Okay? So, the call site is obj.something, and this will work. Okay? Just be careful. Okay. I mean, I must say in JavaScript we are not going to use this that much. Sorry for the word trick. But when you see the code and code written by others and so on, you might like using object-oriented programming styles and so on. You must be careful. Okay, that's the message. Rule number 3, explicit binding. That's less useful because we typically don't do this by ourselves. It's typically done in libraries and so on. But you can explicitly tell a function to use an object. So bind an object to a function, so that when the function is called, the this is attached to a specific object. So instead of calling the function with the brackets, you use the method .call or .apply to the on the function, which I remember you, it's an object in JavaScript, so you can write the name of the function .something because it's an object, and these are predefined methods that every function has, and you can explicitly attach an object. Okay, so this is attached only for this call, and you can attach an object permanently using the method bind. Okay, so this is just done for one call, and if you use the bind, it's done for all subsequent calls that you will do on this function. Okay, it's a way to say, okay, when you call this function, this object is attached to the function, so that this will have this value. Okay, But as I told you, it's typically done only in libraries and in code that has very peculiar purposes, and it's not just for, let's say, normal use. Fourth rule, we already saw this. Actually, if you call a function with new, it's a constructor function, so basically the this will refer to the newly created object, okay? That will be later assigned to obj here, because it's a return value of the function as well, okay? That's the more intuitive one, I think, okay? Because new, it means you create a new object and you get a new object as a result, and you can access the new object with the this, as you do in many other object-oriented programming languages. Okay. I think we can skip this slide, just the technicalities, but since we are not going to see the prototypes and so on, I mean, it's probably not so useful to go deep into this many details, okay? So the summary of the rules is, you call it with the new, that's a newly created object, this newly created object. You use call or apply or the bind. Okay, you decided which object is attached because you pass it to a function. Okay, so either call or apply or bind. Is the function called with a context? It means it's called as a property of an object, that this is the object. Otherwise, nothing. Okay, in strict mode, it's undefined. That's all. Almost all. Because arrow functions are an exception to this rule. Okay, they are not just a convenient way to define a function, a nicer syntax, so with the arrow, but also behaves a little different about the this. Okay, so arrow functions adopt the this binding from the enclosing function scope, or if there's no enclosing function, from the global scope. Okay. So we need to go back to the enclosing function and see what is the this value for the enclosing function. Okay, so it's really handy in event handlers and callbacks, because basically you don't really know, when you're going to call this function. Okay, and you're not the one that is calling this function. Okay, so basically. The this will have the value that is available outside in the outside scope, in the enclosing scope. Okay. So in short, I mean that this will be set for us by somebody else, but we can use this in our event handler. So in this function that we will be called later. Okay. Again, to determine which value has the this, okay, we need to go outside in the outside scope and see which value has the this in the outside scope. Okay, and in this case, which is similar to the previous one, okay, we have an object. We attach the object explicitly to the call when you call foo, okay, and so the this in foo will refer to obj, and so the this in the arrow function that can see the outside scope, that is the foo scope, will see the same exact value, so the obj, okay, that in this case has been explicitly attached, okay, to the function. Okay. Otherwise, we could have written, another field and call it with the field dot foo. Okay, just an example. But I mean, this will be natural for us. I mean, we will write event handlers. We will write them as arrow functions. Try to remember to write them as arrow functions, so everything will work automatically in case you need to use this. Okay. So these are the summaries, really the final summary. So there are the 4 rules: new, explicit and binding we call apply or bind. Implicit when you call it as a method on an object. Default, never use it. And arrow functions enclosing scope, okay? Which is actually a closure over the this variable, okay? Just to recall you what a closure is, okay? At a certain point, the disk goes out of scope, but as with any other JavaScript function, when things goes out of scope, that means they go into the closure, if you can still use the function, okay? But just a technicality here. So, I mean, new, or call it on an object, or use the arrow function, and that's all, okay? So, long story made short is just 3 rules. New, call it on an object, or arrow function when you have event handlers or callbacks, okay? That's all about the this. It's worth remembering because, as you saw, it's quite peculiar, right? And of course, you can go into more details if you like. I mean, there's plenty of resources on the web or in books about these things. Okay, so if there are no questions, I will go on and I will proceed, telling something about libraries and packages. Okay, my colleague Antonio in the last lecture on Monday already introduced you to a very simple package that was the day.js. That's actually because we needed it in the lab. Okay, just not to start with something really basic like we do some math operation and stuff. I mean, really basic for you. Okay, so you could use and do something a bit more interesting. But now we are going to see more details about these concepts and how this concept, how packages, libraries, and so on work in JavaScript. So first of all, let's try to define, what a package, library, and also a module is for JavaScript. Let's start from the easiest thing, a module. A module is simply a JavaScript file that has its own scope, which is isolated from the rest of the JavaScript code that you have. Okay, we will talk a bit into more details about modules later. Okay, because they will be useful later when we go inside the browser. Let's say. Okay. What's a library? Well, a library, in short, is a group of scripts, modules, and so on, so code that implements a desired function. So it's more a conceptual definition. Okay, a library is some code that we can use to do some operations that are quite recurrent in our code. Okay, and so somebody maybe already coded them for us. And the package. It's one or more libraries organized so that can be easily integrated into projects. Okay, so depending on the programming language that you are using, there might be packages or just libraries. Okay, in all their style programming languages, you find libraries typically that basically are already compiled pieces of code that you can link together when you compile and so on. In more, let me say modern programming languages, especially scripting languages like Python, like JavaScript and so on, you find packages. That means libraries, in short, that you can easily import and use it in your programs. Okay, even without compiling and doing all the stuff, even if the language is not does not have to be compiled and so on. Okay. Packages are quite convenient, okay? But to support packages, we need a place where these packages can be put, and a software that can handle packages for us. Otherwise, we go back to libraries. I mean, we need to download a file or more files, a zip with some files and so on, put it into the folder of our source code and so on, and do everything manually. If things has been packaged well, and we have a software that can specifically deal with packages, so a package manager, we simplify the use of this library and code that is made available to us because the package manager automates the managing of the packages in a standardized manner. So it basically helps us to download, import, and configure packages for our project, for our code. Okay? And to do this, especially for downloading the packages, there should be a place where I go and can download the stuff. Okay? And this package, this place, sorry, is a registry. So it's a sort of database, a list of software packages which are available. They have a title, a description, and a URL from which you can download the actual code. And this package manager knows the place of the registry, and when you ask for a certain package to the package manager will go to that place, search the list, and see if the package exists. It downloads and does everything that is needed to make the package available to your code, okay? With all dependencies, all the stuff that is needed to make it work. JavaScript support packages. Actually, there's quite a large number of packages in JavaScript registries. I mean, there can be more than one registry. Okay, and the registry is managed typically by an organization, often a foundation or some organization that does it, to make a service to the community. And the largest JavaScript registry is the NPM registry, which has this URL. And we can click it and have a look. Okay, and here it has also a web interface, but the web interface is just for convenience. It's just to browse for packages for you, for people, for humans, for programmers. Okay, the JS. Okay, you search it, and you find. I mean, the stuff for there are packages with this name in the name, in the description, and so on. And you can click and see some explanation of whatever has been put by the developer of the package. In this case, the JS package. Okay? But you don't go here to download the package. The package will be downloaded automatically by the package manager. Otherwise, the procedure would be just, have a look at the website or search on Google and download something. That's the same. Okay? If we have a package manager, we can automate this process. Okay? So there are different package managers in JavaScript. You might have heard about other ones, but we will focus on NPM. That is the same that you used on Monday. And that's the default package manager for the Node.js environment. Okay? So you install Node.js, as you probably already did for the lab. And you don't know, but you also installed this NPM package manager. If you type NPM on the command line, you will see that it's a program to which you can give commands. Okay? So actually, just be careful that also, NPM is also, the name of a repository platform. Okay, I mean sometimes the name of the program is the same of the name of the repo and so on. Okay, I mean for our purposes, this is a quite basic course. I mean there's really no difference in using one package manager or another. But I invite you to stick to the instruction what we see in the course, just for simplicity, okay? Because that's what we know better, and that's the place where we can help you better if you have problems, okay? But of course, you are free to, to try something else just to learn, okay? For the exam, okay, this NPM is required because we will need to install the packages and we will need to have the same procedure for everybody. Okay, so how does the package manager work? Well, the developer has to decide to install a package or to use a package. And so it needs to tell the package manager to import a new package in the project, and the package manager does everything written here automatically. So it goes to the software registry, checks if the package exists, obtains all the information, downloads the code, and put it into the project in a standardized form, as you saw last time, this package.js, and it writes the name of the package, the version, and so on. And today we will add some information about this package.json. And also, importantly, check dependencies and restart from 2 in case you need dependencies. Okay, the JS is quite simple package. I mean, there's not so much code in that package. I mean, it's just, code that handles dates. So it's boring to write, but I mean, you don't really need anything else, to use it. But there might be more complex packages that require other packages, and the package manager will know that there are dependencies or other packages needed to make this package work. It will download them and install them automatically. So later in this course, I mean, maybe today or only next Monday, we will use a package that handles a database. Handling database is a more complex thing. You need to handle files or network connection and so on. So you need to use other packages for these specific purposes, but we just ask to install the package that handles the database, and the rest will be done automatically by the package manager. Okay, that's one example. I mean, I decide I need the day.js. I will ask the package manager to install the day.js in my project. But also it works in a different way. So somebody else gives me a project, and this project requires the day.js or whatever package. Well, if I have a list of packages that are needed in my project, I can tell the package manager, well, have a look at the list and install everything is needed by the project. So the package manager can also read the list of packages required by the project and install them automatically. That's the typical situation when you download code from some places and you want to use it. Okay? Typically, who wrote the code also used packages, and there's a list of packages required by its code, and it simply gives you the list and you install it yourself. Okay, they don't give you the packages as well, because the packages are the same and are available from the package repository. So the developer only shares the application code and does not need to care about the other code, so the packages that will be managed automatically. Okay, so we saw the day.js example, and we saw that using npm is very easy, right? We go into an empty folder and we write npm init. You remember, we can do it again, but it asks you a few questions, but they're just basic questions. I mean, do you want to give a name to your project, a version, and so on? Really basic stuff. It creates a first version of the package.json file that is the list of the packages needed by your project. And then you tell the package manager to install some packages like day.js or whatever we need. Okay? And the final structure is what you see here. So, I mean, I suggest you to write to work in a folder as you would do with any project. Okay, one folder for each project, just because it's more convenient. You don't mix things together. And also for the package manager, it's easier because You only have the list of the packages that relates to the project that is in the folder. So there was one of you that asked me before starting the lecture, I mean, should we use, put the files, all the files we develop in the same folder? How do we manage this list of packages and so on? Well, my recommendation is a new project, a new folder, and so a new package JSON file that is the list of packages needed by that project. Okay, just for making things clean. Okay. I know it might be not so convenient, especially if you have a lot of dependency, because dependency will be installed in a folder, this node modules folder. I mean, packages and dependencies, and so this folder will grow and will become quite big. Okay, but you know that if you have multiple packages, multiple projects, you will have packages, and for some projects there will be some packages which are not the same as other projects and so on. And also for us in this course, it's not a big problem because typically we will install small packages. Okay, I think the biggest one before using React and the web development and so on will be typically the database one. Okay, but I mean we are talking about a few megabytes. We are not talking about so much code. So let's have a look at the structure that is created by the npm init and then the npm install with some packages. Well, there are always these three items. So first of all, node modules, it's the folder where the packages are installed. In short, don't touch this folder. The only thing you can do is delete the folder in case there are problems and you want to re-download and reinstall the packages and the code. Okay? But don't touch anything inside the node modules. It's completely managed automatically by the npm package manager. You can have a look at the package JSON and the package lock JSON, which are similar. Okay? Package JSON is very readable. We already saw the example here. It's a sort of object, okay, a JavaScript object. It's not really an object. We will talk about later about the JSON format later. But you see there's a key value pairs, and of course it's not JavaScript code. It's just a way to describe information. So you can have strings or other objects or numbers and so on. Okay, but this is basically strings. So there's a list of dependencies and the name of the package and the minimum version required. Okay, and the package lock JSON is similar, and we will go into more details in a minute. And then what's this fourth file? Well, actually, the rest of the files are your files. It's your project. You can put whatever you want there. Okay. I mean, you can have QA.js, index.js, XSS3.js, whatever you want, okay? You develop in this file or in these more than one files, depending on how you organize your code, okay? For the moment, we only have the possibility to use a single file, and we stick to this approach, okay? And when we have modules, we can use more files more easily, okay? How do we use the packages? Well, we insert the require statement as you already did for the day.js. Okay, require with the name of the package, and then you use it. And how to use this? How to use the package? Well, actually, it depends on the package, depending on how people who developed the package decided to make it work. Okay. So for the day.js, you just call day.js with empty parameters, or it will return an object. Okay. How do I know how to use it? Well, that's where the web interface becomes convenient. Okay. Typically here, you will find examples how to use the package you choose. okay? Or with any, programming assignment you get, you either search on Google or nowadays you ask to ChatGPT and so on, okay? And you start from those points and you can explore yourself what's happening. I mean, printing the return value of the JS, okay, the JS call and so on. But of course, I mean, starting from a place where that you trust, it's a bit better than just searching randomly on the internet. Okay, so I mean, if you have a getting started or just the example and so on, try to start from there and build from there. Okay, good. Okay, so what time is it? Okay. Okay, so let's just try to do it again as you did last time with the Visual Studio Code. I've seen what my colleague Antonio has done. So just to show you, I mean, this is what my colleague Antonio did last time, right? So that's actually what is published on the web, right? So that's the lecture examples, right? So the week 2, just these example vehicles. Okay, we don't care, but the QA, and you have this S3 QA package lock and package JSON, okay, that have been created by my colleague Antonio on Monday, right? And so how do I run a program that is this S3QA.js that require this package, the JS? I don't have the package installed at the moment here. What I'm going to do? I have this package manager. I need to use it, right? So just make sure it's there, right? npm, yes, it gives something like node, right? .exit. So when I install the node also installed this npm manager. So first, go in the correct directory. Don't forget it, right? No, week 02 QA. And you see there are these 3 files that I'm seeing here in the environment, in the development environment. Okay. But then, how do I run this program that requires the package? Well, I cannot simply write, as I did last time, node with the executable file because module not found. Something is missing. Cannot find module.js. Okay? Well, I didn't install it. My colleague did it. It has the package on his computer, not on mine, right? But he gave me the source code that is S3, actually published on the GitHub, and the package JSON, which we can open it. They are text files, so we can have a look at what's inside. Okay? So, dependency, that's an important part. The rest is, we don't care for the moment. I mean, we don't care in general. I mean, just the name and so on. But dependencies, .js. Okay? And so, how do I install the dependencies once they are listed in this package JSON file? npm install without any parameter. If I want a specific new package, I need to give the name. Without the name, if there is already a package JSON file, so a list of dependencies, a list of packages required by the project, well, I just, install it with npm install. Okay? So actually, it added one package and did something else. We don't care. You see that a new folder has appeared, this node modules. Okay? It wasn't there before. But actually, I don't want to see what's inside there. It's managed by the package manager. You can open it if you're curious, but I mean, don't care. Okay? Now, if yeah, don't forget, to run this npm install, you need the network connection, because the package manager went to the npm repository, checked for the presence, for the URL, it downloaded the package, and it installed here. Okay, to download, of course, you need the connection and to check. Okay, and now I can try again to run the program. Node S3, yes, and something is printed, so you know, depending on how he wrote the code, you will have some printed stuff. Okay, so the program has run, and that's okay for us. Okay, so very easy stuff. You can, in case there are problems, you can simply delete the node modules. Okay, move to trash. We are back to the initial situation. No packages. Just give npm install, and it will reinstall all the packages. Okay, automatically for us. That's the purpose of the package manager. And now it works again. Okay, so you need only to distribute these 3 files. So the code, of course, the list of dependencies with some additional information, but we don't really care, and this third file that we will see in more details in a minute. Okay? Okay, good. If there are questions, just feel free to ask. Let's try to finish the discussion about the package manager. So, you know, you are from the cybersecurity course of study, so it's better that it's good that when there is the chance, we have a look at the security aspects as well. We are not trying to cover all possible issues in security. There's plenty of other courses that you will take in your course of study about this. But you know, when it's really important and it's easy to cover and to point out, we will try to do to focus on security. And so we will spend a few words on security here at this point. Because, I mean, it's really nice, right? I typed the npm install and everything worked. Okay? And the JS came from the repository, it was installed, and so on. But actually, if you think what you did is that you downloaded some code from the internet, and then you execute your code on your local machine with the same privilege as all the rest of your code, same possibility to access data that has the rest of your code, and so on. So that's a big problem. How can I trust this code? I mean, this is code like the one I wrote. If there's a piece of code that says delete everything, it will delete everything. It runs with the same privilege as the rest of my code. Okay? So it's a potential security issue, right? Also, your code depends on something which is external. It's a package that is stored somewhere in the internet. If this package is not available, your code will not work anymore. Because it's like if you miss a library when you are compiling the code, like in C code, C++ code, and so on. So there's both a security issue and availability issue. If I don't have the network connection, I mean, well, I search another network connection. But if the website, I mean, the place, the repository has disappeared, what do I do? Okay? So it's an availability problem. Okay? How do I run my project if I'm missing a piece of the project, actually, because the package is something that is needed by my project? Well, I mean, there's no actual answer, especially to the security points, to the security issue. Well, you know, you have an entire course of study to learn some techniques that can help you, you know, to address these problems. Well, first, I would like to point out, well, don't forget to check if the code has problems. I mean, you know, it's a common issue that code that you downloaded and store in repositories and so on might have known issues, bugs, or also vulnerabilities. Okay, so that's a command which is really handy. But just to show you, that is something that npm audit. Okay. Okay, let's say, well, at the moment, according to the repository where I took the package, there's no known vulnerabilities. Okay, that's good. And you will see that if you run this command after a while, probably it will print something. I mean, a while, I mean a few weeks. Okay, because probably some issues like security issues or similar bugs and so on will be discovered and will be updated on this repository, and you will see that if you continue to use the same version of the package and not an updated version that fixed the problem, you will risk incurring in bugs or security issues and so on. Okay? Okay, there is also this nice command, audit fix. I mean, that basically does only one thing. It takes the latest version of the package and it replaces the older one that you have locally on the system. Okay? So it's not really fixing anything magical. It's not AI and so on. I mean, just download the latest version, which hopefully has been fixed. Okay? That's all. It's convenient. It's a package manager. It just needs to handle packages, and it's like npm update. Okay, I mean, not really. The command is not the same, but I mean, in conceptually, just update everything to the latest version, and hopefully everything is fixed there. Okay. About security. Well, trusting others' code is always a problem. I mean, either you do it yourself or you delegate the problem to somebody else. Okay? So either you take the code, have a look at the code, try to understand the code, and check if you see any strange behaviors, functions, and so on, or you trust somebody else. Okay, so you hope that somebody else did these checks, and it gives you a pointer to some code that is secure in this sense. Okay. I mean, there are different ways of trying to validate or make sure that code is secure. Okay. I mean, security in absolute terms doesn't really exist. I mean, you can never know if everything has been actually checked or not, because new things get discovered every time, and there's always one thing that you didn't think about. Okay, but you can try at least to use the available tools like formal verification tools that I think you will see soon in this course of study. Or I mean, if you don't know what to do, you check it yourself manually. You look at the code if it's not too much, and or you trust somebody like the people behind the package repository, the npm registry. Hopefully, they did some checks for you. Okay. So the point is just you need to be aware of what you are doing. Okay, that's the important point, at least for this course. Okay, you need to be aware of the fact that the problem exists, and you are delegating, the security checks to somebody else. And when you delegate these checks, make sure you delegate things to somebody who is trusted by you. Okay, not some unknown trusted entities and so on. So when you download some random code from the internet, or even when you ask ChatGPT and so on, and you take the code, copy and paste into your project, I mean, the only one that can check if the code can be trusted or not, it's you. Okay, you need to read the code, understand what's happening inside the code, and see if it's reasonable or not. Okay, or you need to trust somebody else, but it means that you cannot simply cut and paste from whatever place, but you can only download packages with a procedure that we will see. It guarantees that what you downloaded is the same thing that has been checked on the remote site. Okay? So, after somebody has checked the package, we have an approved package that, I mean, should be, we should be able to use it, let's say, securely in our organization, company, project, and so on. Okay? So somebody guarantees, in a certain sense, that the code is secure, and so you download that package, and you trust the organization that says it's secure, and you use the code. Okay. And so the problem becomes how to ensure that the package is distributed securely. How can we force package managers use only approved packages? So, I mean, we are downloaded from a website, but we must, I mean, from an URL, I would say. But we must be sure that what we downloaded corresponds to what has been checked by this trusted entity that guarantees that the code is safe. Okay? Well, I mean, if you are downloaded from a remote place, and you don't trust the communication channel and so on, the only thing that you can do is to check if there is some signature applied to the package, typically a cryptographically secure hash that matches the hash that is distributed by the entity that checked the package. Okay? So you check if the signatures are the same. If they are the same, the package is actually what has been checked by that entity. And so you can trust the code. Or what is done in serious big companies, because it's really expensive in terms of resources to do, is use only a private registry. That means that you can only install packages from your own registry, from within your company. Okay? So basically it means that somebody has downloaded some packages, has run checks, have a look at the code and so on, and in your project you can only use the approved packages from your organization. Okay? That's the only other option, which by the way is good because it also solves the availability issue, because it's a repository in your organization. So if something doesn't work, if something disappears, it means you go to your colleague and you ask, what did you do? I mean, restore from the backup and so on, and you have the code. If it's an entity somewhere in the internet, you cannot really do that much. I mean, you can hope, send an email and hope that somebody will solve the problem. Okay? Okay. So, I mean, the first option is the good one, but it's really, really expensive in terms of resources. You need to have like a department dedicated to this issue, okay? Because, you know, checking packages, a lot of code and so on, it requires a lot of effort. So, let's focus for a moment on the second option. Even it doesn't guarantee the availability. Well, if we have an hash, so it means the signature of the package, and we are able to check this signature, that's something that can be easily done by a package manager. And that's the purpose of this package lock.json file that we saw before. Okay? The package lock.json file contains both the hash and the version of the package. Actually, the version was also in the other file, but let's have a look. Here, the version it says, this symbol means equal or greater than 1.11.13. Okay? The other one says, well, the actual installed version here is 1.11.13, and that's the hash, cryptographically secure hash of the package, and that's the URL that you should use to download it. Okay? So, of course, the first time we don't have this hash. So either we give this hash in some ways, and we find the hash somewhere, I mean, from this trusted entity and so on, or the first time we have no option than trusting what has been downloaded from the repository, including the hash. Okay, but from the second time on, when we reinstall the packages, we can check if what we install is the same as what we installed the first time. So the hashes match. Okay. Good. So in short, always use the package lock.json file and distribute it with your code, as we actually did last time. I mean, my colleague committed both the package JSON and the package lock.json, and you are required to do this for the final project as well. I mean, it's not really fundamental because we are playing with the code, okay, in this course. But when you are in a serious environment and you are caring about security, safety, and so on, you should always use this package lock.json because it contains the hash of the packages and also the version that has been used to develop the code. Okay? So you saw that before we used this npm install command to install the missing packages in the project. That's a possible way, but not a recommended way from the security point of view. Okay? It's better to use this npm CE, that stands for clean install, because it starts from scratch, it downloads everything, and it checks, well, both checks the hash, but it also installed the exact same version of the package that is specified in the package lock.json. It means that npm CE, without the package lock.json, it will not work. While the npm install simply need a list of dependencies, and it downloads what it finds in the repository. Okay? So let's try again. I mean, the result will not change, but conceptually it's different. So let's delete the node module again. Let's delete. Okay. So npm CE. Okay. The result is the same, but I got the exact version that was specified in the package lock.json, which at the moment is also the latest version. But I mean, I invite you to try in a few weeks, and maybe you will have Node DJS 1.11.14. Okay, you try npm CE, you will download the version 13, which is also safer from the point of view of reproducibility of your code, because your code has been tested with a certain version of the package. Okay, and that is also why we write here it's recommended for automatic reproducible builds, because you never know if somebody has developed a new version that broke some functions, code, and so on. Okay, once a version has been committed and put into the repository, this cannot be changed anymore, because everybody has the hash, and it will refuse the code if the hash doesn't match. Okay? If you create a new version, of course, you should start from scratch and recheck the code, recheck the safety of the code, and so on. Okay? Indeed, that's what, I mean, that's what in serious companies you do when you know, there are major versions of the code, you don't really want to update the code every time there's a new version in the repository, because you have to check the code again, okay? At least the differences and so on. So it's true that this approach is limiting you a little bit, but hopefully, you know, you gain a lot in safety, and that's why you should try to follow this approach. We don't have the resources, you know, to follow this approach here in this course, and so the only thing that we will require is just, you know, to use this clean install and require to have the package lock JSON, which is also good from the reproducibility point of view, okay? When you deploy something in a system and you need to build everything from scratch, you give the source code and you need the packages to be included in the code and so on. If you have the same exact version, is also good, because you know that everything is exactly the same as you tested before the deployment, okay? Last recommendation, and then we will have a short break, is, you know, choosing libraries and packages is very, it's a delicate operation. You need to be very, very careful, okay? Of course, there are very well-established packages, and typically what we recommend in this course, it belongs to this category, okay? So the DJS, the SQLite we will see later, React, Bootstrap React, etc. A lot of packages that we will see. But, I mean, you might be tempted to search for some packages that solves your problem, or maybe the ChatGPT and so on suggests you to use some packages. Just be careful of what you're using. You need to consider, well, I mean, this is not really technical, but more, you know, organizational. It belongs to the how the company is organized. I mean, first of all, can you use the package? Does the license allow you to use the package? Because then you run into trouble if you cannot really use it, okay? For instance, especially for commercial purposes when you're not in a company and so on, okay? And if you build on a package and then you discover you cannot use it, you need to, you know, develop code again with maybe another package and so on, okay? And then most of these projects, packages and so on are community supported. So make sure you choose something that is well supported. I mean, there's a community behind this package, especially if it's a big one, because otherwise you might risk that at a certain point the developer or the few developers behind the package stops developing, fixing issues and so on, and basically you are alone. I mean, you have the latest version that you checked and you're sure it works, and then that's all. But, you know, bugs and security issues will only increase over time. Security, of course, you know, the reputation of the developers of the package is really important. I mean, if it's a big company or organization, it typically has a better reputation than a single developer maintaining a package in the spare time that he or she has. Okay, I mean, it's not a guarantee, but I mean, of course, if a company has a lot of resources, it means money, programmers, and developers to put behind the project, it's probably better supported and better developed. Okay. And then, last but not least, I mean, documentation and code quality. Have a look at the code. I mean, there's nothing wrong. I mean, I told you not to look into node modules, but I mean, just to, you know, have an idea, I mean, you can open some files. I mean, if it looks like a mess, probably it's better not to use it, okay? I mean, I told you not to open it just because it's automatically managed. From the point of view of using it, you don't need to have a look at the code. But, you know, have a look at what has been done inside. I mean, it's always useful. And documentation. Unfortunately, this is a very you know, it's a delicate point. I mean, because nobody wants to write documentation because it's boring and so on, right? But in very well-maintained projects from big companies and so on, typically documentation is quite good because documentation is really important. It tells you what to do and especially what not to do. Okay, common errors, common problems, and so on. Okay, so just, you know, beware, consider all these aspects before choosing libraries and packages. This is, in a certain sense, also part of the security process, okay, safety process. Because if you choose something, you know, from people that you wouldn't trust in your life, I mean, as a person, and probably you don't trust the code as well, okay? Yeah, this is just, you know, to summarize the discussion. I mean, you know, try to choose something which is well supported and it supports you well, okay? We can end with this, you know, word trick. If you have any questions or comments, I mean, feel free to ask. Otherwise, in the second part of this lecture, after the break, we will continue with the topics of JavaScript, talking about asynchronous programming and so on. Okay, as it's written in the schedule. No questions, I assume. So let's break for 10 minutes, and then we will resume with JavaScript. Okay, thank you.